Hello and welcome. Thank you for tuning in. This is going to be another exam paper walkthrough from AQA. We're looking at GCSE Maths and we're going to be looking at AQA past papers in this video. The paper in particular we're going to be looking at today is the June 19 paper 3F. So that's the paper 3 foundation, so calculator paper foundation tier. Attached to the description of this video, you'll find a link to a Google Drive where you can download a copy of this paper. I would strongly recommend, to get the most out of the video, you've either already done the paper or you do it alongside the video. Either will be very helpful. I'd also recommend put some music on in the background. I tend to listen to some music while I'm doing exam papers. That's recording them or doing them for myself, just to make them slightly more enjoyable. So I'd recommend that for you guys as well. If you find this video useful, please do subscribe if you like. And before we get right into the paper, what I'm going to do is, so this is the exam analysis from when this paper was sat back in 2019. This gives you some idea of the kind of marks that you need for various grades, which is quite useful. So roughly you needed sort of 58 marks for a grade 5 on this, and so on. It also gives you how well the questions were accessed by students of particular grades, which is quite useful. Quickly from this list, what I can pick out is this question here came out particularly low: algebraic argument, sorry, misreading there. It's a good job on maths, not English. Typically speaking, that was done the worst. Got a car alarm going off in the background, which is causing me a slight issue. Okay, so this is a copy of the paper. Today I'm going to be using an FX 570 emulator. That may not be the version that you're using. That's absolutely fine. It's just a convenient emulator for me to be using. Okay, question 1, circle the value of the digit 2 in the answer to. So this caused a few people kind of rushing in. They just worked out the 2 of the value, not the sum. So the value of the sum would be, in effect, we knock a 0 off, so 520. So the 2 value would be 20. Okay, question 2, solve x minus 5 is equal to, x minus 8 is equal to 5. So in effect, what we're going to do, stop trying to say in effect, what we're going to do is add 8 on both sides, and that will give us x is equal to 13. So x is equal to 13 is going to be that option there. Question 3, circle the fraction that is equal to 2 1/4. So I'm not saying that you need to do this, but it's a useful skill. You can enter a mixed fraction on your calculator by pressing the shift and then the fraction button, and that will let you enter it as a mixed fraction, 2 1/4. And then that will automatically convert it for you. If you're on a non-calc paper, in effect what you're doing is the whole number multiplied by the denominator plus the numerator all over the denominator. So that's going to be 8 plus 1 is 9, so 9/4. Okay, question 4. Circle the expression that means x divided by y. So x divided by y, let's take the words out, x divided by y, which can be written as a fraction, x over y. So we're looking at the first option. Question 5, put these numbers in order from the smallest to the largest. So the easiest way to do this on a calculator paper is to convert them all to be in decimals. Obviously I won't need to convert that one, and I can do these two without a calculator. Although if you want to use a calculator, that's absolutely fine. 31/40. And I want that as a decimal, 0.775. Right, now that I've got them all as decimals, what I'm going to do is I'm going to add in some 0 placeholders to make them all 3 decimal digits. So this is 3 already. If I add a 0 there and 2 zeros on that one, then I can just compare the decimals and view them as normal numbers in a way. So 775, 750, 700 and 725. So the smallest one in this list then is this one. The next smallest one is this one. The next smallest one is this one, and then finally we've got this one. So if we put them in their original form, then we've got 7 over 10. We've then got 0.725. We've then got 3 over 4. And then finally 31 over 40. Right, question 6. Josh downloads an album A. A has 11 tracks. Each track on album A costs the same. The total cost of downloading A is £3.80. Josh also downloads album B. B has 14 tracks. Work out the total cost of downloading B, assuming the cost for each track is equal. That's really wants to get a feel for the question. So I've got an album. I need to work out the average price of a track on album A, and then I need to work out how much that average price would cost me for album B. So we've got 11 tracks that cost £8.80. So to work out that, I'm going to do 8.8 divided by 11. And then to work out the price for 14, I'm going to times it by 14. And that will, I can type that in just like that on my calculator. If you've done it as 2 separate steps, that's absolutely fine. So as a decimal, that's going to be £11, 11.2, which is going to be a price of £11.20. Part B. In fact, compared to the cost of each track of A, the cost of 6 tracks on B is more by 5 pence. The cost of 8 tracks on B is less by 5 pence. What does this tell you about the answer to part A? Tick one box and give a reason for your decision. I don't actually need my answer for part A to help me with this, really. The cost of 6 tracks is more by 50 pence, so that would have a residual effect of 6 times by 5, or 0.05, technically speaking. So that would be create 30 pence more. 8 tracks less by 5p would create a residual of 40p less. So overall, the track would be 10 pence less. So the total cost is less than my answer to part A. That would be the one that I want. Give a reason for your decision. Well, this is really my reason, and I can describe it. But I can just give the overall statement. It would be 10 pence less. That would be absolutely fine because I've justified it here. I could go into detail. I could say the cost of 6 tracks being more by 5 pence would create 30p more. The cost of 8 tracks being less by 5p would create 40p less. So overall, it would be 10 pence less. But that's in effect what I've done there. So that's absolutely fine. Okay, question 7. Pictogram. Pictogram shows information about the houses in a street. Each house has 3, 4, or 5 bedrooms. There we've got the pictogram. In total, how many bedrooms do these houses have? So this is quite an interesting pictogram question. They're not that common. We're not working out the total number of houses. We're working out the total number of bedrooms. So I'm going to do this. I'm going to keep it in terms of pictures, and I'm going to say, thinking of a technical way of doing it, I'm not going to do it overly complicated. So I'm going to say 3 times by the number of pictures, 1, 2, 3, 4, 4.5. And I'm going to put the times by 2 in here, but I could have put the times by 2 in overall at the end, but I'm going to keep it this way. Plus 4 times by 1, 2, 3, 4, 5, 5 lots of 2, plus 5 bedroomed houses times by 1.5 times by 2. And I would typically type it into my calculator like that. I'm going to just show you how I could have written it instead though. So 3 times by 4.5 plus 4 times by 5 plus 5 times by 1.5, and then I could have times the whole thing by 2, which is just slightly easier to type in. So there are 82 bedrooms overall. Right, question 8. 4 positive whole numbers add up to 84. One of the numbers is a multiple of 17. The other 3 are equal. What are the 4 numbers? Okay, so we've got four numbers, 1, 2, 3, 4, that add up to 84. One has got to be a multiple of 17, so it's got to be in the 17 times table, so or 17n. And then the other have got to be four equal numbers, so I'll say a plus a plus a. So that's the situation that I'm in, but then they need to add up to 84. So that's in effect kind of written that down. So what I'm going to concentrate on is the multiple of 17. So multiples of 17, so I've got 17, 34, my next one is going to be 51, my next one would be 68, just double check that, 17 times 3, ooh, helps if I typed it in right. Yeah, and then I'm going to see what would actually happen if I did that. So what I'm going to do is take away that from 84 and see if the numbers are divisible by 3. So if I do 84 minus that, 84 minus that, 84 minus that, and then if I need to carry on, 84 minus that. So first of all, 84 minus 17 is going to give me 67, which isn't a multiple of 3. So it can't be that one. My next one then, 84 take away 34 is 50, which again is not a multiple of 3, so it can't be that one. Then 84 minus 51 is 33, and that would be a multiple of 3. So that means that my numbers are going to be 51, 11, 11, 11. I'm just going to carry on just to see whether there's another one. I don't think there is, but we'll see. 84 minus 68 is 16, which is not a multiple. And then there's no point in going any further because the next multiple is going to be bigger than 84. So that's the only option. Right, question 9. Jim wants 10 rolls of wallpaper. He sees these prices. Wallpaper, single roll, packs of 3, packs of 10. What is the cheapest price for 10 rolls? So seems like a straightforward question, but that's actually quite a nasty question. Let's look at it. My options are I could have 10 lots of the one roll. So I'm going to say this is the one roll price. My second option is I could have, if I think about making 10 rolls out of the 3, if I just go for that, then that would be 4 times by the 3 roll price. However, you'd also get 10 rolls by having 3 lots of the 3 roll price plus 1 roll, because that would give me 9 and then an extra roll. And then I could go for the 5 rolls. And then I need to work out these prices. Technically speaking, I don't necessarily need to work them all out, but we will work them all out for this purpose. So times by £12.50. I don't really need to do that on a calculator. That's going to be £125. 4 times by 34.5 is going to give us 138, and I'm fairly confident that won't be the price because this one will be cheaper than that. So 3 times by 34.5 plus 12.5 is going to be 116. Cheapest one so far, and then we can kind of see that this isn't going to be cheaper. So 2 times by 58.75 gives us, as a decimal, £117.50. This is my cheapest price. What does it ask for? What is the cheapest price? It doesn't ask us to describe how we found it. The cheapest price there is going to be £116. Now, a lot of students didn't spot that one, and they just worked out these 3 prices. And if you've done that, let me just bring up the mark scheme. What it says is What it says is, looking, my prices don't seem to match what they've written. My cheapest one is obviously right. Yeah, it says 117.5 will get you 3 marks. So if you've not done that and you followed that method. Yeah, so yeah, that works fine. So yeah, our cheapest price is going to be 116. Okay, question 10 then. In rectangle ABCD, the triangle ABE is an equilateral. ABE is an equilateral. Triangle CDE is isosceles, where CE equals DE. Work out the size of angle X. Okay, so I'm going to put this information in just to make it so this is an equilateral triangle. So let's just add those. Then we got CE, we've got that one up marked down already. Right, equilateral triangle then. Because of that, these would need to be 60 degrees. Because don't really need the angle itself, those angles are equal, then it actually means that this angle here will also be a 65 degree. You can work that out, you can argue that a number of ways. You could say that we've actually got similar triangles here and here. Because it's a rectangle, but that's absolutely fine. So that's information from the question kind of transferred over. This would create a 90-degree angle here, which means that that's got to be 30 degrees. And then we can work out X by saying it's going to be 180. So let me just rewrite that. I'm going to say that X is going to be equal to 180 minus those two known angles, so 65 plus 30. So that's going to be 180 minus 95 is going to be 85. Okay, question 11, complete the number machine. So input of A, blank here, times by 5 equals that. So what I'm actually going to do is I'm going to divide that by 5, and that will give me my answer. So 5a divided by 5 would be a. Sorry, I'll do it here. It will be a, and then plus 5. Sorry, plus 2. So if we started with a, so that must be 2. Sorry, plus 2. And then for the second part, write down y in terms of x. So we've got x divided by 2. So at this point here, we've got x over 2. And then plus 4, so y must be equal to, write down the output y in terms of, so that's going to be x over 2 plus 4. Right, question 12. First 4 triangle numbers are, circle the next triangle number. So for triangle numbers, they go up. So we need to add 5, so 15. Write down all the prime numbers between 40 and 50. So we're looking at, I'll list them all out to start with. 42, 43, 44, 45, 46, 47, 48, 49. Right, so I'm going to get rid of all, I'm just going to do kind of a quick check. So get rid of all my even numbers. I'm then going to get rid of all of my multiples of 3. I'm then going to get rid of all of my multiples, any other non-prime numbers. So 7 is going to 49. And then that gives us all of my numbers. So 41, 43, 47. On a calculator, you can check this. Yeah, I will spend a minute doing that. I was debating whether it's worth it. If I take a non-prime number to start with, if I go shift and then if I put the number in and then I go shift and then fact, that gives you the prime factors of the number, which tells you it's not prime. So for any one that we wanted to actually, I believe that's a prime number. So if I press fact, it just gives me 41. So it says that there are no factors of that. 43 equals shift fact, no factors of that one, and then 47 shift fact. There we go. And then again, if I, for example, hadn't spotted that 49, if I press equals and then press shift fact, it breaks it down into its prime factors for me. So that's just a way of double checking. Okay, question 14. In this question, use 1 cubic foot equals 6.23 gallons. 1 cubic foot equals 0.28 cubic meters. Okay, convert 3,115 gallons into cubic meters. So we're going to convert from gallon. Okay. So we're going to convert it into cubic feet and then into cubic meters. So the way that we would do that is, so we've got 3,115, and then to convert from gallons to feet using this conversion, I'm going to be dividing. So I need to divide by 6.23. And then when I want to go cubic feet into cubic meters, I would be timesing. So times by 0.028. And I can do it like one sum. There's no particular need, provided you've shown what you're typing into your calculator, for you to include an additional step. You just need to make sure that what you've typed in is correct. So starting value divided by the exchange rate times by the exchange rate. Yeah. So we're looking at 14. All right, question 15. Circle the correct statement. And then we've got 3 statements, all relating to a third and 30%. So technically speaking, a third as a percentage is going to be equal to 33.33333333. So it's not equal, and it is not equal. So a third is less than, it's greater than. So that's the only correct statement. And I think that's quite a little bit tricky, because initially I hadn't looked at it in a lot of detail. I assumed that these were opposite sides of an inequality, but they both say a third is less than or equal to, or a third is less than. So they're both incorrect. So that's the only correct statement. Question 16. Which shape must have rotational symmetry? Rotational symmetry. Circle your correct answer. Okay, so I'm not a big fan of this question. I know the answer that it's after, but I will often say that all shapes will have rotational symmetry of at least order 1. Because if I looked at an isosceles triangle, for example, span it around a center point, it would overlap itself once when you span it 360 degrees. So you could argue that it has rotational symmetry of order 1. But you could argue that for any shape. The one that would have more than 1 would have to be the parallelogram. The parallelogram has to have order 2. Because if you imagine spinning that round, it would overlap itself after 180 degrees and again at 360. So I'm going to go parallelogram, but I'm not very happy with the wording of that question. Okay, question 17. Shop sells ice cream. Each ice cream has 2 scoops. The possible flavours are vanilla, strawberry, chocolate, and mint. The 2 scoops can be the same flavour or different flavours. List all the possible combinations of the 2 scoops. Are we given particular space to do that? Not particularly. So I'm going to do it with a strategy. I'm going to do V first of all each time. So I could have a V and a V, a V and an S, a V and a C, and a V and an M. Then I'm just going to switch each V starting letter. So S and a V, S and an S, S and a C, S and an M. Then C and a V, C and an S, C and a C, and then C and an M. And then my final ones are all starting with mint, M and a V, M and an S, M and a C, M and an M. List all of the possible. So that's the listing. And just again, the 2 scoops can be the same flavour or different flavour. So VV is allowed, SS is allowed. Think about that in a bit more detail. So technically, my question here is, doesn't really state it in the question. So is S and a V the same as V and an S? So what I'm going to do is I'm going to circle those options and then check the mark scheme, because it could well be that they don't allow those. I don't think they've been specific enough in the question to state whether they're. List all the possible options for the 2 scoops. So those could be viewed as the same option. I don't think it's made it very clear. List all the possible options. Right, let's have a look at the mark scheme. And the mark scheme says exactly 10 options or exactly 16 options for the full mark. So needless worry there. But again, I don't think they've been specific enough in the question. Part B, on 1 hour, the shop sells 180 scoops of ice cream. The number of scoops of each is shown. Complete the pie chart to represent this data. Okay, I'm going to have to bring in something to help me with the pie chart, but I'll do that in a moment. So the first thing I need to look at is there are a total of 180. So the angle size for each is what I need to work out before I even pick up a pie chart, pick up a protractor. So in effect, the angles are going to be double because the angles need to be at 360. So to get from there to there, I'm times in by 2. So we're looking at 90, 150, 100, and then 20. And then we can double check that adds up to 360. So let's go 90, 240, 340, 360. So it does. So that's the angles that I need to draw now. Let me just see whether I can get a decent-ish protractor emulator. Okay, I can't do this particularly well, but I can make do. Right, so technically speaking, my protractor is going to be a little bit smaller than that one. So technically speaking, that's going to be my protractor. What I do is so this is what I refer to as the 0 line. And I'm going to put the 0 line at working along the first line of the protractor, and I'm going to put the center of the. So let's just put a little mark there. So I'm going to put my center of my protractor on that and making sure that the 0 line runs along the first line. Right. First angle then is 90 degrees. So I put a little dot at the side, and I can then remove that and draw a straight line from the center of the protractor through the center of the angle. See whether I could insert a ruler, but I can't. So I'm just going to do a straight line from the center of the protractor through the center of the angle. Right, that then becomes my 0 line. Well, I can put in that that's vanilla. Right, my next angle then 150. So my protractor goes again on the center, and then I need to spin it around. And spin is awkward, but you'll get the idea. So I'm slightly out. Then I'm measuring 150, so that's going to be making sure I start at 0. 150 is going to be around here, so put a little dot again. Take my protractor off, and then another straight line from the center of the pie chart through that dash. And then that's my next section, which was strawberry. And then my next one is I want a 40-degree angle, so I need to spin my 0 line round there. And I'm measuring 100 degrees, so that's going to be there. Again, a straight line through the center of the angle, through the center of the circle and through the protractor. So that's going to be my next one. It's chocolate. And then provided I've done that correctly, my final angle should already be 10 degrees. So let's just measure it. It's always good to check. So I'm a little bit out. So I'm a little bit out. Let's just work out where I've gone out. So I'm confident of my 90-degree angle. Looks slightly over 150, but not by a lot. So, tractor. There we go. So I'm a little bit out here with my 100. Yes, I've misread. My mint section should be 20, and it's very close to 20, so it's perfectly fine. I hadn't really made a mistake at all. So we'll put mint on that final section, and that's the chart. Okay, question. So I've obviously drawn the pie chart separately. Question 18, on the grid, draw an enlargement of scale factor a half. We're not given a point of enlargement, which is absolutely fine. So we pick a point to start drawing our triangle, and then all of the dimensions are halved. So instead of being 4 across, my new triangle is going to be 2 across. Instead of being 2, 4, 6 up, it's going to be 3 up in the center. So that's going to be my enlargement. Obviously, you're going to draw it with a pencil. Drawing it freehand. But that's going to be my enlargement. Half as big. Okay, question 19. Fully simplify. So we're collecting like terms here. So if I collect my a squareds first of all, so 3a squared minus a squared is going to give me 2a squared. I'm then going to collect my a's. So plus 7a plus 8a is going to be plus 15a. Then I've got my number parts left. Plus 4 minus, plus 3 minus 4 would be minus 1. Drawn that a particularly well. Right, fully factorize. So both of these have got a number and an algebra term in common. So the highest common factor of 24 and 20 is going to be 4. And they've also got a y in common. So what would I need to times 4 by to get 24? That would be 6. And then y to get y squared would be y. And then what would I need to times 4 by to get 20? That would be 5. And so that's going to be my fully factorized 4y open bracket 6y minus 5. And then solve. Okay, so When you square root a number, technically speaking, you're going to get a positive and a negative value. And I'll bring the calculator in to help me with this, just to fully explain it. But my calculator will only give me the positive value, but I want the square root of 196. That's going to be 14. But technically speaking, 14 times 14 then is obviously going to be my answer, 196, but also minus 14 times minus 14 will also give me 196. So technically we've got plus or minus 14. So we've got both values, minus 14 and plus 14. Don't need the plus for the second one. What does the mark scheme say? So if you've only got 14, you can get one of the two marks, I think. Yeah, B1. Right, question 21. To the nearest pound, John has £9. To the nearest 50 pence, Ellie has £6.50. Work out the maximum possible money. Work out the maximum possible total amount of money. Okay, so if we look at John first of all, if John has £9 to the nearest pounds, then his money has got to be bigger than £8.50, but less than £9.50. If we look at Ellie's, Ellie to the nearest 50p, so that's got to be £6.25. Sorry, yeah. It's the minimum value. The maximum she could have would be £6.75. So work out the maximum possible total. We're going to be taking those two values and adding them together. So 9.5 plus 6.75 gives us £16.25. Right, I'm considering this a second time. So when we do bounds, we would normally take the maximum value, but technically speaking, we're not going to be using the maximum values here. So I don't think that's going to be quite right. So what I'm going to actually say is 1 pence less. So £9.49 plus £6.74. I think is going to be the actual value that we're after, £6.23. Right. I think that one's going to be the right. Right, let's look at the mark scheme. What does the mark scheme say? Yeah, the mark scheme's quite not harsh, but if you've gone for £16.25, you only got 2 of the 3 marks. You lose a final mark, £16.23 for 3 marks. Right, question 22. Here is a formula. Work out the value of t when n is equal to 5. Okay, so I'm going to use my calculator for this and just type it in like that. So 5 squared plus minus fraction 12 over 5. Double check that that's what we're after. It is. So that gives us 113 over 5, which I think would be fine, but if we give it as a decimal, 22.6. Why is t always positive when n is negative? So when n is negative, this kind of refers to a skill that we've already done. N squared will always be positive. Positive. 12 over n minus 12 over n will always be positive. So P will always be positive. I was vaguely thinking, could it ever be negative? So could this value be bigger than this value? But it doesn't ask. So in theory, could 12 over n be greater than n squared? And I think it actually could, but it doesn't say. But that would be a positive value. So for example, if it was 1, that would create a negative value. But it says it's always positive when n is negative. So that will always be true. Okay, question 23. In 1 hour, a machine can make 600 nuts or 720 bolts. At 3 p.m., the machine starts working. It makes 900 nuts, then changes to make bolts. How many bolts will the machine make by 8 p.m.? Okay, so the first thing that we're going to look at is the time. So 8 p.m. minus 3 p.m. equals 5 hours. So the machine is going to be working for 5 hours. First thing that we need to work out then is how long it will take to make 900 nuts. So that's going to be 900 divided by 300. Divided by 600. Which is going to give us 1.5. 900 divided by 600. Divide out 1.5 hours. So we've got a remaining 3.5 hours. So 5 minus 1.5 is going to be equal to 3.5. So we've got 3.5 hours left. So it makes 720 bolts. So our final step is going to be 3.5 times by 720. So 3.5 times by 720 gives us 2,520 volts. So 2,520. Okay, question 24. Two solids, J and K, have the same density. Complete the table, including units in your answer. Okay, so we're using the fact that density is equal to mass divided by volume. So we're going to work out the density of this one first of all. From that, we've got the same density here, and from that we can work out the volume. So the first one has a density of 48 divided by 8, which is going to be 6. So we're looking at, let's get rid of those lines. So both of these are going to be 6. We need to include a unit for them though, and that's going to be grams per centimeter cubed. Right, so we need the volume of K then. So K, the volume is going to be equal to, if we rearrange that formula, M divided by V. M divided by D. So that's going to be 78 divided by 6, which is going to be 13. Yeah. So that's going to be 13 centimeters cubed. Okay, question 25. Right, this is going to be an awkward one to do on the screen. Towns P, Q, and R are connected by roads. Okay. P to R is 10 kilometers longer than P to Q. P to Q is twice as long as P to R. The total length of the three roads is 170 centimeters. Work out the length of PQ. Right. So I'm going to start with one variable. So in effect, I've got three roads. Then QR, QR. Order P to R, P to Q, and Q to R. Right. So which one am I going to call X? I'm going to call it's the one. Typically speaking, it's the one that's going to be referred to twice. Would be the easiest one to call X. So PR is 10 kilometers longer than PQ, so that would be X minus 10. And then Q to R is twice as long, so 2X. Let's just double check that I've read that correctly. P to R and P to R is referred to as twice, so I'm going to call that one value X. Simpler. PR is 10 kilometers longer than PQ, so PQ would be 10 less. Then QR is twice as long, so that would be 2X, and their total is 170. So if we add those three together, then we would get 4X 10 is equal to 170. So 4X is going to be equal to 180. So X is going to be equal to 45. And that was what we were asked to work out. That wasn't what we were asked to work out. We were asked to work out P to Q. So that was our. So PQ is 10 less than that. So PQ is 35. Okay. Question 26. Mia wants to borrow £6,000 and repay it with interest after 2 years. She sees two loan offers. Offer 1, compound interest of 3% per year. Offer 2, compound interest, first year 1%, second year 5%. I will pay back the same amount because the average is 3%. Is she correct? Is she correct? My initial gut is I will pay back. I will pay back because the average of So in my head, I'm thinking I can be really cheeky here and say that that statement is definitely incorrect, because that's not how compound interest works, and that should be enough. So I'll be awkward and say no, compound interest take the average. The 2 years. And part of me wants to argue that would have to be correct, but the way that they would expect and the way that I should really do it is to show that that's not the case. So if I look at offer 1, so offer 1, and work out the total amount, it's going to be, again, the initial starting point doesn't really matter, it's the overall interest. So I could say whatever the interest was times by 1.03 squared. And I am going to be slightly awkward with this. So that's going to be whatever the initial investment was, 1.03 squared. So the overall interest would be 1.0609 for offer 2. Again, the initial amount doesn't matter. It's going to be what the multiplier ends up as. So it would be 1.01 times by 1.05. which would be 1.01 times by 1.05. So it would be 1.0605. So that would definitely be enough to get me my full marks. However, most people would have actually worked out what the final value was. So in effect, 6,000 times by 1.0609. So the amount that she has to pay back with from offer one would be £3,665.40. For offer two, the amount would be five. They're not the same. So kind of three ways there. Arguably, I think no compound interest won't take the average of the 2 years would arguably be enough, because even if it was the same, that's not the reason. Same amount because the average of 1 and 5 is 3%. Method two, I've just looked at what the multiplier would be for both of them. And then in the purple, I've actually worked out those two figures and shown that they're not the same. So all three would lead to the conclusion of no. Right, question 27. Here are two sets of numbers, set A and set B. The mean of set A to the mean of set B is 3 to 8. Work out the value of x. Okay, so the mean of this number to the mean of this number. So if we work out the mean of this one first of all, so the mean of set A is this how I want to do it? So I'm not actually going to look at the means. So technically speaking, I'll explain this as I go. So the mean of set A to the mean of set B would be equal to 3 to 8. So the total of set A to the total of set B. Well, for set A there are 4. And for set B there are 1, 2, 3, 4, 5 numbers. So the total of set A to the total of set B would be 12 to 40, and both of those numbers, so that would be 6 to 20. 4 is going to them both, so that would be 3 to 10. So I'm going to look at the totals just because I think that's easier. So the total of set A then is, so the total of set A is 200 plus 160 plus 104 plus 100. So 567 to head. Yeah. So the total of set A then is 270 plus 400 plus 483 plus 300 plus x. So 1473 plus x. Right, so that means that 567 divided by 3 is going to be equal to 189. So this total needs to be so 10 times by 180 is going to be 1,800. Equal to 1,473 plus x. So x has got to be equal to some 9 there. So the total for that x must be 417. So let's just check over my working. So I've just looked at the answer and I'm out by a little bit, and I'm just checking over my working, which is the way you should do. So I'm confident up to this point here. What I think is I might have worked out these totals wrong, and it might have been me talking and writing down at the same point. But if I add up my 4 values for set A again, 160 plus 104 plus 100, gives me 464. So I'm out by a number here. So 564 should have been my total here. If I did the other numbers, 270 plus 400 plus 483 plus 300, and I'm out here as well. So 1453. So actually, to get from there to there, what I should have done is wrong number, 564 divided by 3. That should have been 188, which means over here we should have been timesing by 188. So my value here then should have actually been 1880 is equal to 1453 plus x. So x should have been equal to that by 10 equals, and then take away 1453 instead, 427. So 427. Right, yeah, that's the way I'm going to go for that. That's definitely the right answer. If you'd done it this way, your calculations here would have been slightly more complicated, and you would have been finding x over 5, which is why I chose to do this manipulation at the start. It should have been much more simple if I hadn't made that mistake with my 2 calculations there. Always check your working. Okay, question 28. Straight line has a gradient of 4 and passes through the point 523. Work out the equation of the line, giving your answer in the form y is equal to mx plus c. So if we've got a gradient, so it's going to be y is equal to 4x plus c. And then we're going to use this coordinate 523 to find out our value for c. So that means that 23 is equal to 4 times by 5 plus c. So that's going to be 20. So 3 is equal to c. So the equation of the line would be y is equal to 4x plus 3. So again, I've got a feeling that I might have paused that. So if the gradient of the line is 4, that means the y is equal to 4x plus c, because that would be m is equal to 4. From there, we plug in our coordinate 523 to find our value for c. So 23, that's the y coordinate, is going to be equal to 4 times 5. So that's the gradient times by 5 plus c, minus 20 from both sides. 3 is equal to c. Okay, question 29. 2 sides of a triangle have a length of 13 and 27. Which of these is a possible length of the other side? Circle your answer. Right, so first of all, if we assume that that's the longest side, then 27 minus 13 is equal to 14. 7 minus 13, 14. So our final value has to be greater than 13. Because if it was 13, if it was less than 13, you'd have a 27, and then your other 2 sides wouldn't meet. So it's got to be greater than 13, but it's got to be less than. If you imagine that these two were not the shortest side, if you imagine 27 wasn't the longest side, 13 plus 27 is going to be equal to 40. So it's got to be less than 40 because, again, with the same principle, if that's the missing side, if we've got a 13 and a 27, they wouldn't meet. So it's got to be greater than 13, so it can't be that one. So it can't be 13 or 40 because that wouldn't work. And I've made a slight mistake. That's 14, so it's got to be bigger than 14. Why? So there we go. So it's got to be 27. Right, question 30. Here is a right angle triangle. Use trigonometry to work out the size of angle X. So by trigonometry, this side would be the opposite and this side would be the hypotenuse. The trig ratio that involves an O and a H is the sine ratio, SOH. We want to find the angle. So X is going to be equal to sine to the minus 1 of the opposite, 13, over the hypotenuse, 16. So check my calculators in degree mode. Got a little d there. So shift sine, and then we'll type it in as a fraction. We'll type it in as a fraction if I press the right button. 13 over 16 gives us the value of 54.3409 ... not rounded. It doesn't ask us to round to a specific amount. Use trigonometry, so I'm going to go. This is to two significant figures, so I'm going to go to 3. So 54.3. And that brings us to the end of the paper. Right. And again, I'll bring up the question level analysis, see how you did on that. Again, that gives you the average mark for grades at the top over here. And again, that refers to how complex the questions were. Question facilitated by grade tells you, so for example, a grade 3 student on average got 2 marks, 2% of the cohort got marks for this argument. If you've got a particular topic that you struggled with most, I will reference or chapter link all of these topics into the chapters of this video. So if you want to go to a specific question, you can. And that's where you would aim your independent revision. So again, thank you for watching. I hope you found that useful, and subscribe if you like.